Good morning. We're going to get started. Welcome. We have some participants that are on the phone and we're recording today, so we will take questions at the end, but we will have an opportunity for questions, so if you'll just be patient and hold them till then. And I do have the participants on the phone on mute for now, and we'll also open that up at the end. So welcome to today's presentation of the prioritization results for the preservation of Louisiana historic bridges. I'm Amy Squitieri with Mead & Hunt. I am the consultant project manager for this project, and I'm joined in the presentation Christina Slattery, also with Mead & Hunt, the senior historian. She'll come up for a part of the presentation. We have been working on this project for 2 years, and we finally reached a milestone that's very important to the outcome of the project and the state's effort to identify and preserve those historic bridges in Louisiana that can continue to serve a transportation function. We also have here today members of our advisory team, and those, the project is sponsored by the Department of Transportation and Development and the Federal Highway Administration and supported by the State Historic Preservation Office, and each of those agencies makes up our Historic Bridge Inventory Committee. So I see at least a half a dozen members of the committee in the audience. If you just want to raise your hand, maybe somebody will identify you for a question later at the end. We also have some new participants here today that I believe are new to the project, so welcome, and I'm glad you can join us. So some of these folks are owners of the historic bridges, so special welcome to you. Just a brief background on Mead & Hunt. We're the prime consultant for this project. We're an engineering and architecture firm that's recognized as a national leader in historic bridge preservation. Our project team includes historians and engineers that specialize in assessing, documenting, and rehabilitating historic bridges. And we've received support on this project from sub-consultants from TRC and Coastal Environment that are both located here in Baton Rouge, and I know we have someone from Coastal Environment here today. Very important help on the project. Just really briefly, and for some of you this is a recap, just wanted to review what our overall project purpose is. This is to facilitate and simplify the Department of Transportation and Development, the bridge owner, and the Federal Highway Administration compliance with federal historic preservation regulations. We have worked to identify bridges that are eligible for listing in the National Register, as well as those are not eligible for the National Register, so that we now have a definitive list so that every bridge owner knows whether preservation compliance is required or not for the particular bridge. If it's required, if it is a historic bridge. If it's not a historic bridge, then you don't have that consideration. And next important purpose is to identify bridges that are good candidates for future preservation and to focus efforts on these bridges in order to streamline efforts for the bridges that are not good candidates for preservation. So you'll see how we arrived at these results in the presentation. And finally, the purpose of developing a programmatic agreement for regulatory compliance that streamlines project development where federally funded or permitted projects affect a historic bridge. And we have a meeting that many of you may be coming to following this presentation that continues our development of that programmatic agreement. All right. One behind on these slides. Next I will recap really briefly the steps in the project that have taken us to where we are today. The project has been going on for 2 years, as I mentioned, and there are 5 key steps. And now we're at the last step, which is identifying bridges with preservation potential. Throughout this process, we've conducted public involvement and consultation with agencies, owners, and interested parties. And the presentation and the consultation meeting that are being held following the presentation are part of this public involvement and consultation step. the first 4 steps in the process led to the outcome that we have presented here, which is the identification of historic bridges. We analyzed the state's entire pre-1971 bridge population of more than 4,500 bridges. The reason for the pre-1971 is that there's a 50-year general requirement for historic bridges. That's a minimum criteria. But there is also a desire to have a planning window because projects take a while to develop, and the state doesn't want to do an effort like this, more than every 10 years. So that is the reason for the cushion there. So starting with that population, we surveyed bridges in the field. We conducted research and collected data on bridges that had potential significance based on the National Register of Historic Places criteria. And then applying the criteria and placing bridges within the historic context of Louisiana's transportation and bridge engineering history, a total of 150 bridges were determined eligible for the National Register, and that represents 3% of the total population. And then the remaining 4,400 plus bridges were determined not eligible, and we have the agency concurrence on that, and now have that definitive list. This slide breaks down that population of historic bridges by type, so that you can see here that movable bridges that represent the largest segment of the population. They're an especially important part of Louisiana's engineering heritage. In the detailed listing that you see on the side here, it shows the variety of movable bridges that are in the state. Several of these types are distinctive to Louisiana, and the sheer number of movable bridges also sets the state apart from a national perspective. I'll also point out there are 17 truss bridges, 9 concrete arch bridges are all in a city park in New Orleans, and then there are examples of other types that have been identified as important for their engineering and or historic significance. Also note that there's a population of 28 bridges that are excluded from, as we develop the further steps in the project. Those are bridges that have been found historic but will not be part of the streamlining effort of the programmatic agreement. And the reason for that is either due to their ownership, which is in some cases federally owned, and those agencies aren't party to the agreement, or they're privately owned. And then there's some other bridges that are where a project has already been underway for a while, and the bridges will be replaced in the near term. So with the population of historic bridges set, we moved to the major step of the project that involved developing and applying criteria to establish which bridges are most suitable for preservation. And this step was developed in consultation with our Historic Bridge Committee that I mentioned earlier. Applying this approved methodology, we categorized each bridge into one of these 3 categories. And those categories are the preservation priority historic bridges. There's a commitment to maintain these bridges and rehabilitate them when a rehabilitation project is needed. The next category is the preservation candidate historic bridges. These bridges are designated for maintenance and preservation when it is prudent and feasible. And then the non-priority bridges. Those are not ideal candidates for long-term preservation, and they can be removed and replaced when needed following standard mitigation practices. We'll share examples of bridges in each category, explain the reasoning for the placement in the different categories, and provide more information as to how these bridges will be treated in the future based on the categorization. Next, I'd like to explain how we arrived at these results, and we did provide a handout at the front that gives you a version of this, what you see on the screen that you can read if you'd like to follow along. This is a summary of the process by which a bridge is placed into its appropriate treatment category, and we're going to walk through the steps that are summarized here. At the top, you see that we start with historic bridge pool by type. The reason that we looked at bridges by type is that the historic bridge team was committed to the goal of preserving bridges that represent the breadth and important variety of bridge types that are present in Louisiana. So within the pool of bridges in a particular type, our next step is to calculate a bridge's condition score. And this slide shows the factors that go into this calculation, which allow us to isolate factors that indicate whether a bridge's preservation is prudent and feasible. Bridges within the pool by type are sorted by the score, and a high score indicates high preservation potential, and a low score indicates low preservation potential. And this range for scores is 0 to 93, with 93 being the highest score possible. Next, we look at the additional considerations for bridges that have a condition score that's greater than or equal to 40. So 40 is the threshold that we use there. Bridges that score below 40 are found to have significant deficiencies that make preservation difficult and imprudent. And we'll explain each of the 5 considerations in the next series of slides. First consideration is rehabilitation. This consideration is met in one of 2 ways. Either the bridge is currently doesn't have rehabilitation needs, so the condition is the current condition is good, or the bridge has rehabilitation needs that can be met to allow the bridge to remain in vehicular use. If deficiencies can reasonably be addressed by a rehabilitation effort that adheres to the Secretary of the Interior standards for rehabilitation, then it meets this consideration. The Secretary of the Interior standards are a National Park Service a document that's been in use for decades, and it is a guidance for preservation that maintains the historic integrity of a property such as a bridge and allows it to remain eligible for the National Register. So a bridge may need rehabilitation activities to continue to serve its function, and those can range from addressing corrosion through cleaning and painting of steel components of the bridge to more extensive measures such as addressing structural deficiencies that could be caused by section loss in members or rehabilitating damaged railings. So those are some of the types of rehabilitation activities that were considered. In this example, the anticipated rehabilitation activity is addressing corrosion issues. So our next consideration is the geometrics. And there are different scenarios in which a bridge would meet this consideration, and the consideration measures whether the geometrics on the bridge are adequate. So if a bridge is on a low-volume road, then the low-volume standards, which are a federal standard, are considered, and the bridge is evaluated to see whether it meets that standard. For a bridge that's not on a low-volume road, then we had the reference of the state's minimum design standards, so we evaluated whether a bridge would meet that. Few historic bridges meet that state minimum standard. So our next consideration here for geometrics was that the engineer evaluated whether the geometrics would be satisfactory for continued use, looking at factors such as the number of lanes on the bridge, the current traffic volume, the width of the bridge compared to its approach width, sight distance, and whether there was any evidence of vehicle damage from the bridge being hit in the past. So those are the geometric factors. Next, we go to the third consideration, which looks at the load capacity of the bridge. Under this consideration, the live load capacity of the bridge is reviewed to determine its adequacy. Fourth, we have the consideration of detour and bypass length. For this consideration, we look at the load posting of the bridge, if there is a load posting, and consider whether there is an available, acceptable detour route for vehicles that would exceed that posted load. And what was considered to be acceptable was less than a 10-mile detour route. Our final consideration, consideration 5, looks at navigation control and restrictive factors that can affect a bridge. The navigation controls, navigation protection, and horizontal and vertical navigation clearances for movable bridges, as well as for fixed bridges that span navigable waterways, are evaluated under this consideration. For movable bridges, if navigation control is required and protection is adequate, and if the required horizontal and vertical clearances are met, the bridge meets this consideration. Another part of this consideration 5 addresses restrictive factors such as a bridge that is over a railroad crossing. Bridges over active railroads are reviewed to determine if rehabilitation of the bridge would constrain future railroad operations. Here's a bridge over a railroad in Webster Parish. And then the final restrictive factor that's considered here is a bridge that is part of a spillway. So this consideration, we look at bridges as being located on spillways that their future preservation was potential was limited by the possible need to modify or expand the spillway. So as I explained earlier, it was important to this the project outcome that we had bridges that were prioritized for preservation that represent the breadth of types of bridges, historic bridges present in Louisiana. So we had, for the 6 bridge types that you see here, there was a special effort that was required to identify a candidate that we called the best of type. And we'll explain how this consideration worked as we talk about examples. But just briefly, within these 6 types, no preservation priority bridge was identified in our initial application of the 5 considerations. Therefore, the pool within each type was further evaluated to identify the one bridge that offered the best potential for preservation. And here we gave primary consideration to the live load capacity and whether the bridge is located on a truck route and whether alternate routes were available. Since bridges in this situation, they most likely will require rehabilitation to remain in service because they do have some deficiencies, the bridge that was chosen as a preservation priority is the one that best demonstrates that it's both feasible and prudent to preserve. So applying the methodology for categorizing bridges into the 3 types resulted in the following selections. The methodology was developed and the results were applied with full participation and consensus from the Historic Bridge Committee. So we have, you can see the results here. The preservation priority category has 25% of the bridges. The preservation candidate represents 48% of the historic bridges, and the non-priority is 27% of the historic bridges. So next, I'm going to turn it over to Christina, who will share examples of bridges within each of the 3 categories.
Okay, now that Amy's described the methodology, let's look at some of the examples of bridges within each of the 3 categories. So we'll start with preservation priority. Just as a refresher, so the preservation priority bridges, those are ones that have the condition score that's greater than 40. That's in the top box there. And then the bridge met all of the additional considerations. Also, as Amy described, we had the 6 types where we had to select a best of type, and the one that was selected as best of type in those 6 bridge categories became a preservation priority bridge. So preservation priority bridges, there's a commitment to maintain these bridges and rehabilitate them when needed. There'll be individual bridge management plans that are expected to be prepared that outline short and long-term maintenance and rehabilitation needs and also projected costs. So our first example is a vertical lift in Vermilion Parish built in 1964. This bridge has a condition score of 66, so well above the threshold of 40. It met all the additional consideration checks. So it met check 1. Recommended rehabilitation for this bridge is to address corrosion, which can be done according to the Secretary of the Interior standards. It met check 2. It has satisfactory geometrics. The transition between the approach roadway and the bridge does not create a bottleneck. And then the bridge also carries 4 lanes of traffic, so there's no geometric concerns. It met check 3. There's no load capacity concerns. It's not load posted, so it met check 4. And then check 5, it's a movable structure, but navigation control is required, but it's adequate for the structure, and there's no other restrictions. So thus this bridge, meeting all of the 5 checks and having a high condition score, is recommended as a preservation priority structure. Our next preservation priority example is a concrete arch in City Park in New Orleans. This structure has a condition score of 83, and it also met all of the 5 additional considerations. You can see it's in good shape and good condition, so there's no rehabilitation needed, so it satisfies check 1. For check 2, it's approach roadway width, and the approach roadway width and the bridge width are both 36 feet, so there's no geometric concerns. The bridge has good structural capacity, so it meets check 3. Check 4, it's not load posted, so no need to consider a detour in this case. And for check 5, no navigation controls required as it's located in City Park, and there's no other restrictions. So again, with a high condition score and ability to meet all 5 additional considerations, it's a preservation priority structure. Our third preservation priority example is a best of type. It's a pony truss swing bridge built in 1959. There were only 6 historic bridges in this category, and this one was identified to be the best candidate within this group for preservation. The structure has a condition score of 47, and it meets 3 additional considerations. It meets check 1. It was recently rehabilitated, including painting that you can see here, and no rehab activities are anticipated in the near future. It meets check 4, load posted, but there's a detour bypass available that's acceptable. It also meets check 5. As a movable structure, navigation control is required, and it is adequate for this structure. However, this bridge doesn't meet check 2 for geometrics. ADT is 1400, so it doesn't meet the low volume standard. But the approach roadway width is 33 feet, and the bridge roadway width is 24 feet, which is a constraint. But when looking at comparing this with the other 5 examples in this category, that was something that was found to be acceptable for keeping this one as a best of type. In addition, this bridge didn't meet check 5, load capacity, because it was inadequate. So although it doesn't meet 2 of the consideration checks, this bridge was determined to be best of type based on the analysis of other pony truss swing bridges and a cumulative analysis of those structures with their condition scores and additional considerations. So thus this was selected within that group to be the preservation priority example as best of type. Next, we'll look at some preservation candidate examples. A preservation category bridge, again, means that the bridge has a condition score that's greater or equal to 40, and the bridge must meet the additional consideration 1, rehabilitation, and meaning that it can be rehabilitated in accordance with the Secretary of Interior standards. Historic bridges in this category are designated for maintenance and preservation when prudent and feasible. And the programmatic agreement, a culmination of this project, will outline a streamlined method to assess rehabilitation alternatives once a structure is programmed. So our first preservation candidate example is a steel plate girder double leaf vestibule constructed in 1940. This structure has a condition score of 64, so above the threshold of 40. It does meet consideration 1 for rehabilitation, and it meets 3 of the other checks. So it's been recommended as a preservation candidate bridge. So for check 1, rehabilitation, the structure needs rehabilitation to address corrosion and pier protection, but these can be done in accordance with the Secretary of the Interior standards. Check 2, the approach roadway width and the bridge roadway width are both 30 feet, so it's not a constraint. It meets check 3 because the load capacity is adequate. And the structure also meets check 4. The bridge is load posted, but there's a close detour route that's only 2 miles away. However, this bridge did not meet check 5 due to poor pier protection, but the pier protection could be addressed in a future rehabilitation project. So with a high condition score and the ability to meet check 1 rehabilitation, and also meeting check 2, 3, and 4, but not meeting check 5, this bridge is a preservation candidate. The next example of a preservation candidate bridge is this through truss built in 1952. This structure has a condition score of 59. It met consideration 1 and 3 of the other checks, so it's recommended as a candidate. For check 1, no rehabilitation activities are anticipated. It does not meet check 2. It doesn't have acceptable geometrics. In this case, the approach roadway width is 34 feet and the bridge roadway width is 26 feet, which creates a bottleneck. In addition, there's poor vertical sight distance. The structure meets check 3. There's no load capacity concerns. It meets check 4. It's not load posted. And it meets check 5. No navigation controls required, and there's no other restrictions. So again, the structure is a preservation candidate due to its high condition score and ability to be rehabbed, meeting the Secretary of the Interior standards. Our last preservation candidate bridge is a 1921 concrete girder. This bridge has a condition score of 59. It met consideration 1 and also 3 of the other checks, so it's recommended as a preservation candidate bridge. For check 1, anticipated rehabilitation activities include addressing structural concerns related to concrete deterioration and load capacity, removal of overburden, which could increase the live load capacity. And these activities are all found to be able to be conducted in accordance with the Secretary of the Interior standards. It meets check 2. The current ADT is 100, so it meets the low volume standards. It doesn't meet check 3. The load capacity is inadequate. It does meet check 4. The bridge is load posted, but has an acceptable detour bypass that's only 2 miles away. And also meets check 5. No navigation controls required, and there's no other restrictions. So again, this is a preservation candidate bridge due to its high condition score and ability to meet additional consideration 1. Finally, we'll have a few examples I'll show you of bridges placed in the non-priority category. So non-priority bridges are those that have a condition score that's less than 40, or it's a bridge that has a higher condition score, so 1 above 40, but it doesn't meet additional consideration 1 for rehabilitation. These bridges are not ideal candidates for long-term preservation due to their condition and can be removed and replaced when needed. Standard mitigation treatments will be applied, and there will also be global mitigation outlined in the programmatic agreement for these structures. So our first non-priority example is a swing plate girder built in 1935. This structure does have a condition score of 49, so it's above the threshold of 40. However, the structure is not able to meet check 1, so it's recommended as non-priority. It doesn't meet check 1 for rehabilitation because there's cumulative deficiencies on the bridge result for needed extensive rehab work that would be difficult to complete in compliance with the Secretary of the Interior standards. In addition to not meeting check 1, the structure doesn't also meet 3 other checks. Check 2, the geometrics are not satisfactory. The approach roadway width is 36 feet and the bridge roadway width is 24 feet, so we have a constraint there. It doesn't meet check 3, the load capacity is inadequate. It doesn't meet check 5, navigation control is required, but pier protection is in deteriorated condition, which you can see here. The structure does meet check 4, it's posted, but has an acceptable detour route that's only 1 mile away. So again, this is a non-priority bridge because it cannot be rehabilitated to meet the Secretary of the Interior standards. Our next non-priority example is a 1923 concrete rigid frame. Like our previous example, this one has a condition score that's above 40. It's just above 40 at 43, but it can't meet check 1, so it's recommended as non-priority. This bridge would require extensive rehabilitation that would be difficult to complete in accordance with the Secretary of the Interior standards, and those activities would include repairing concrete, addressing debris accumulation. Rehab would also include adding railings and raising the deck surface that's currently subject to significant drainage issues, and you can see some of the water ponding on the deck here. The structure does meet check 2. It has a low ADT of 250, so it meets the low volume standards. It meets check 3 because the load capacity is adequate. It does meet check 5, no navigation controls required, and there's no other restrictions. But the structure does not meet check 4. The bridge is load posted, and its detour bypass length would be 27 miles, which is much more than the desired length of 10 miles, or less than 10 miles. So although this has an adequate condition score and meets some of the consideration checks, it requires extensive rehabilitation and does not meet check 1, so it's recommended as a non-priority structure. I don't have any examples to show you here, but I just want to point out that there are other non-priority examples. The majority of them are ones that have a condition score less than 40, and they're recommended non-priority due to their poor condition and difficulty to be able to rehab in accordance with the Secretary's standards. So now that we've outlined the methodology to identify the historic bridges that are most suitable for preservation and seen some examples, I want to quickly talk about the next and final steps for the project. We have the development of the programmatic agreement and a popular publication on historic bridges. So the development of a programmatic agreement will document and outline treatment procedures for the historic bridges identified through this project. The PA is being developed with the Department of Transportation and Development, Federal Highway Administration, the State Historic Preservation Office, the Advisory Council on Historic Preservation, and other consulting parties. The streamlining benefits for this project as outlined in the PA for historic bridges extend to DOTD and local owners. And these benefits include that only 3% of Louisiana's historic bridges identified as historic, and as such will require adherence to federal preservation requirements, which leaves 97% of the bridges that are not historic and can be maintained, repaired, or replaced without adherence to federal preservation requirements, specifically related to the bridge itself. There will be global mitigation outlined in the PA for effects to historic bridges. The bridge owners will have a clear process to follow to complete Section 106 for preservation candidate and non-priority bridges. And preservation priority bridges are identified up front and can be considered and addressed through proactive planning by owners. All of this results in avoidance of delays in project delivery due to Section 106 requirements. And the final step of the project will be the development of a popular publication on the state's historic bridges. The publication is one of the global mitigation items mentioned in the last slide to streamline Section 106 projects for historic bridges. And the project will end with the completion of the publication and implementation of the PA. So if you want to keep abreast of remaining activities on the project, you can find information on the project website, which is listed here, or you can send an email to Louisiana Historic Bridges to be on the project notification email list. And with that, I will open it up to questions and try to back one more. I'm going to add the folks that are on the phone. I have to give them the opportunity to ask questions too. Audio video.
All participants are now in interactive talk mode.
So we have opened the phone up for anyone who wants to ask a question, and then we'll also invite anyone in the audience to ask a question, which we will repeat so that folks on the phone can hear, unless you want to come up and ask the question. That's also an option. Anyone?
Secretary of the Interior policy. Other code requirements
All participants are now in listen-only mode.
I switched the mode because of the feedback, but if you have a question on the phone, you can type it in and then we'll unmute you. So the question was, to restate, is how do the Secretary of the Interior standards, do they supersede other codes that may apply, including electrical code, or as one example? Is that? Right. Okay. Okay. Right, right. The adherence to the Secretary of the Interior standards does not supersede over other codes. In bridge rehabilitation projects, they would be able to meet the other required codes and comply to the Secretary of the Interior standards. So there are, the standards allow for modernization and updates to a bridge or other historic property, and provide direction on how that would be done so that it is compatible with a historic bridge.
That process, how does that, well, it's only 3% for 10. What we ended up with was nearly half of the movable bridges. Yet in none of the criteria did I see anything that covered it all.
Okay. So I'll restate the question is, part of it was a comment that of the historic bridges, a significant number are movable. So as a percentage of movable bridges, there's a lot of them are historic. And how did we consider needs to update mechanical, electrical systems on movable bridges? And I'll invite somebody from the department to weigh in if you'd like. We did acknowledge and discuss that those needs, movable bridges do have needs for updates. There are many movable bridges that have had updates to their mechanical and electrical systems and will continue to. And we, across the board, felt like that is an improvement that can be done, that is not going to affect a historic bridge's ability to convey its significance. So the systems can be modernized, updated as needed, and a bridge will still be able to have the essential features of what makes it historically significant.
Currently in violation of national legislation.
And I don't know, Ray or Paul wants to say anything, and that is certainly rehabilitation of operators' houses. That's something that is currently being done in some cases. It would be desirable to keep the operator's house and supplement it with, if you need to expand it or build a second operator's house to hold the modern equipment.
So the historic preservation could
Yes. Yes. Yes.
So to repeat, we're discussing that we could have alterations to an operator's house and that could still comply with the Secretary standards. Just for those on the phone.
So David from the department, one of the members of the team had just said that we did have a lot of consideration of electrical and mechanical issues as well as rehabilitation needs for operators' houses, and discussed how those could be addressed. And then for specific bridges that are movable and preservation priority, there will be an individual game plan that would identify the needs and recommend how to address those needs. All right. Any other questions? We'll open up the phone as well. If
all participants are now in interactive talk mode.
anyone on the phone want to ask a question? Anything else? Yes?
All participants are now in listen-only mode.
Okay. So the question was, if you have a bridge that we identified that it could be rehabilitated, but it had a deficient geometric, so it had a need to be widened or another measure to address the geometrics, how would that be done? Would that be outside of the structure? Did I miss anything in the restating? Okay. There were very few bridges that can be widened. It depends on what type of bridge. You obviously can't widen a truss bridge. So it would be we looked at whether the type would lend itself to widening, and perhaps there's a sidewalk situation that can accommodate it. So it is fairly rare that you would be able to widen a bridge to address its geometrics and rehabilitate it in a way that didn't completely alter the structure. Yes, right, yeah. And we could look into the results to see if find an example, but it certainly would be a rare situation. Okay. Right. Yeah. So that's sort of you're accommodating a Huey P. Long. Ray was saying is an example of where you were able to achieve widening, where there is an effect to the historic structure, but as the net of your outcome is better than replacing the historic bridge. So that's a balancing act that you. The preservation, so somebody was saying, asking, did the department agree that if a bridge has inadequate geometrics that you're going to live with that condition? The particular bridges were reviewed to see whether the geometrics were considered adequate. So the preservation priority bridges, they may not meet modern standards, but they're considered adequate for the function that the bridge that serves. And they're the best of type bridges, which are the bridges that have the lowest level of current condition or functionality. Even in those cases, the geometrics and other factors were considered to be adequate for continued use of the bridge. So that would be a reason that a bridge would end up in another category as a candidate if it wasn't considered to be adequate.
Sidewalks, guardrails, elevation where it's flooding, any requirement. How is that going to be handled in the accessibility?
So the question was if a bridge had one of a range of examples of challenges, compliance with electrical standards, ADA, and it needed rehabilitation to address that, how would that be addressed? The bridges that are in the preservation priority category, we've looked at all of these bridges very closely with a lot of data, a lot of review, input from all of the participants in the Historic Bridge team. So for the preservation priority bridges, we have agreed that they can be rehabilitated into the future. So there is a commitment to rehabilitate those if they need it. Some of them don't have immediate rehabilitation needs. And the Secretary of the Interior standards, those will be followed. There will be a provision for the possibility in some circumstances that you would have an adverse effect. Huey P. Long would be an example. You're still preserving the bridge, but you do have something that you need to accommodate that cannot be done in a way that without an adverse effect. So you try to minimize that adverse effect and find the best solution that preserves as much of the historic character as possible. Okay. We'll be here if you want to come up and talk with us about a particular question or a certain bridge. I appreciate everyone coming and the participants on the phone for joining us. So we'll end the recording.
And if you didn't get a chance to sign in, if you could come down and sign in, that would be great.